Didn't we have to go from initial to terminal? And if it was PQ, we shouldn't be going QP. Anyway, something to keep in mind, a lot of vector, what am I trying to say? Ties? Similarities? There's a better word for it. There are a lot of links between vectors and matrices. So what have I done so far, guys? What have I done so far?
I haven't done it.
You found the dimensions.
I don't know if I actually did that.
Oh.
I mean, I kind of showed it. I don't think I actually explicitly stated it.
I'm very confused.
Okay.
Okay.
I haven't done much yet. That's why I'm asking what I have done. I've done -1 times -3 plus 3 times -4. Where did I get those numbers from?
First row and then first column.
First times first plus second times second. Remember, think dot product with the row and with the column.
Oh.
First times first plus second times second. Wait, what is positive 3 minus 12?
Oh,
Something
-1.
involved in that.
-1.
Okay, I have one part of my multiplication answer. One part of my, what's the answer to a multiplication problem in math called?
A product.
Dear God. Izzy, keep going. Doesn't matter that you said scalar. Yes, product. Good.
It does.
No, it doesn't. He's the only one answering. Okay, product.
Okay,
Okay, good.
Producto.
How do I get the next part of my answer? How do I know there's a next part? We'll talk about it.
4 -2.
Nope.
Oh.
Because, pause, what row am I still in?
2.
Oh.
Oh,
I'm
-1
still
3
in
and
my
-4
first
1.
row, right?
Or 2.
I use my first row, first column to get my first row, first column term. I'm going to use my first row, second column to get my first row, second column term. Do you see it?
Yes.
Okay, cool. So I'm going to take this and I'm going to move them over here. Okay, now multiply. First times first,
-2.
-2, plus second times second. Oh, what was that?
3. Wait,
Times-
nothing. Pause.
Thanks. So what's that one going to be?
5. Nope, it's 1.
Woo! All right, we're good. All right. That's okay. Kayla sent me a snap yesterday, and I was like, oh, that's fun. Then, like, 2 hours later, oh, that was my house.
Oh, she was at your house?
Yeah. I just didn't realize it. Oh, that's my
Oh,
house.
isn't that
Oh,
burglary?
my pocket. Anyway.
Was that your house?
You could call the cops.
Yeah, there's like there's a spare key, and I have it like a hide a key thing, and a lot of kids that live or that are there know how to get it. Huh.
Just like in your house.
No, they come hang out with my dog. I mean, he's a huge kid. I have a TV. They can come escape college.
That dog.
Can I come hang out with your dog?
Sure.
Cool.
Probably after you graduate. What else?
Before.
Unless you drop
I know it. I know what it is.
Plus, I'm in Santa Cruz. You have to be able to try.
Well, yeah.
I'll take it.
There you go. That came because of Christmas lights. Question.
Yeah.
Someone had a question, and I was supposed to be answering it. I was
Math. We
talking
are
about my
focusing
dog.
on-
We are focused. It's a Friday.
4 -2
I have no idea what's
and
happening right now.
-3.
Wait, pause, Alec, hold on. First row, second column to get my first row, second column entry.
Sorry.
We did first times first plus second times second, and we mushed it together to get 1.
Perfect.
So we went across as we went down. Whatever I'm pointing to, I'm multiplying.
But what if there's more
-2
than
plus
2?
3. Oh, then I just keep on going however far I need.
So it just becomes more exponential.
Essentially that's it.
What are the tax questions?
Sure. No.
How much you said sure.
Moving on.
Yes.
4 -2.
4. Okay, I'm gonna erase all the circles because they're starting to get in my way. But it is time for us to go second row,
4
first column, and then second column. So 4 times who?
-3.
-3 plus.
-2
Times.
-4.
Real quickly, as you guys are mushing it together, doing your PEMDAS, getting the correct answer, maybe even going over and doing the next one. For those of you guys that are here, we're in the second row, first column. Whatever you point to, you multiply. So -12 plus 8. -12 plus 8. Ends up being -4. So then, 4 times.
4 times 2.
So you go across down,
Oh.
and then you go across over
Yeah, 4
down,
times
and then you just keep on going however long you need to go. So 4 times 2 plus negative 2 times 1. Or point and shoot. 4 and 2 is 8. Negative 2 and 1 is negative 2. 8 minus 2 is 6. Are we okay? See where I'm getting my numbers from. Think dot product. Dot product was that old vector thing where we had u and we had v, and they both had components. And what we, u2. And we did the first times the first plus the second times the second. That's kind of what we're doing here, except we're not doing one vector with another. We're doing one row with one column. So, took the row, first with first, second with second, and we added them. And then we went over, first with first, second with second, and then we added them. So it's time for our third row. First column, going back to the beginning. If you guys need to, you can think about it. It's first, second, second, first, second, second, third, first, third, second. We're literally filling in the entries, and whatever the row is, whatever the column is, that's what we're going through. So, down here at the bottom, it's going to be a 5 times plus a 0 times because we're using the third row, but we're matching it up with row by column, the first column. So we're multiplying by negative 3 and negative 4. And then we're using that same third row, 5 and 0, and now we're taking that same row with the second column, which would be 2 and 1. Or just point and shoot. So we have negative 15 plus 0, that's negative 15. And then we have 10 plus 0 is 10. Now, can you make your calculator get that same answer? Ready, set, go. There are going to be times that multiplying you will want to know how to use your calculator. Ella, do you have any questions? Yeah.
Emily, you guessed one yesterday?
Yeah.
The other two.
These ones?
How you guys keep winning?
We should have mercy.
These ones.
So these teams are like, that you're probably going to like.
Are these ones good?
And yesterday she was really slow. She was so slow that we
These
were
ones were with
Oh,
this,
okay.
right?
Yeah.
Then we go over
Golden Valley and Viewpoint or both.
to the second
Pretty
column.
bad.
Viewpoint's bad.
I thought you,
I
no,
did the same
their
thing.
baseball
Oh.
teams using.
Softball is good.
To see.
Or at least I didn't have much patience.
Viewpoint's cross country is really good.
I don't know.
Anderson.
I don't know.
Their volleyball team.
Well,
They're
Shelburne
pretty good
we
for
had.
team.
Are we talking about Viewpoint or something else?
I have one of my friends from my
We
junior
had
party.
Shelburne.
He
They
goes
hit
to
a home
Viewpoint
run
and
and
like
we gave up.
they're insane at cross
That's
country.
all.
Wait, how do you put this into your cup?
With stonks.
Yeah, like,
Don't you need to make an A and make a B? What order is A as you're putting it in? Mm-hmm.
So now what do we do?
And what order is B? Mm-hmm.
Now what?
Well, you need to go to the home screen,
Rule. Okay.
quit, and then you need to go get matrix A, and actually use the multiplication sign
Oh.
and matrix B. See if that works.
Wait, are we putting in?
It very much did.
Are we
A.
putting in A?
Just A and
The
just
left
B, and then multiply. The whole thing. The
Oh,
3 by 2
just put that.
and the 2 by
Just
2.
that.
Yeah. Is it working?
Yeah.
As soon as you have it, perfect. Can you do B times A now?
Oh.
What size was this answer as you guys are trying to do B times A? What size was this answer? Uh-huh. And it worked. Yay. Dun, 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 dun. It's an error. What does it say specifically, though? It should say more than that.
Oh, yeah. Dimensions mismatch.
Dimensions mismatch. Dimensions. Aren't the dimensions these little guys? It works fine going this direction. I don't get it. Why wouldn't it work going the other direction?
Because the number of lines.
Can we try it the other direction? What would happen if we tried to go the other way with B, ready, Alec? Times A. Okay, matrix multiplication is cross down, row with column. Can you go across and down and have them match their dimensions? First with first, second with second. First with first, second with second. See why it's not going to work? But what's a shortcut to us knowing that? Hey guys, check it. A 2 by 2 times a 3 by 2. I need these two to be the same. I need the number of columns, how many over, to equal the number of rows, how many down, so that they match. So this little thing in here about like when you can and when you can't, I need these two to be equal, and if they're not, then it's impossible.
There will be no solution to something like that.
No solution.
So that's all the same thing.
Yeah. It's going to be impossible, so no solution is the final answer. And here's another reason why, if you want to think about it. This one, this gets hard. Think vectors. This one's 3-dimensional and this one's 2-dimensional. We're not going to multiply a 2-dimensional by a 3-dimensional, but that's kind of hard because one's an over and one's a down. But when we get to word problems with matrices a little while later, maybe we can make a little more sense of how matrices can actually be used to model real-life situations and quantities and stuff like that. Yeah, 11, make a wish.
So, so A times B works, but B times A is different.
Not always, but in this case, yes. Here's a good question. When would A times B and B times A both work out of focus? 2 by 2s. If they're both 2 by 2s, wouldn't matter, right? But they won't necessarily equal the same thing. They'll just both work. How about 3 by 3s? With 3 by 3s or 4 by 4s, by 4 by 4s, what are the only matrices where you'll be able to multiply both ways? Square matrices. Only square matrices. Huh?
The column of the first has to be equal to or greater than.
Because I need them to perfectly match up to my dot product. Because dot product means the first with the first, the second with the second, a third with the third. So since I don't have that extra, I can't measure it up. And if you want to think about it, we're going across and down. I can't have 2 pairing with 3. But I can have 2 pairing with 2. Does that kind of make sense? And it's weird because where the 3 dimensions are here, well, where the 3 dimensions, we're waiting till word problems. So we saw how to put these into our calculator, we saw how to do the multiplication with our calculator, we saw how going both ways doesn't work, and we reinforced when are you allowed to do matrix multiplication? When the insides are the same of the dimensions or of the orders. Okay? Oh, and even more than that, if they are the same, let me get this page put back into the order he should go. Let's get back to the example that we started with today. There we go. Nope. There we go. Yes. Okay. It's not just seeing that it's possible, but guys, check it. These two equal each other. It was legal to do. But not only do you see that it's legal, you also know exactly what size matrix you should be getting out. So in a way, you kind of know what you're headed towards. I need 3 answers and 3 answers. You know that if the 2 by 2 matches, the size will be a 3 by 2. That's exactly what ended up happening when we did that process. I think cross down, and then cross over down. And then that gets me, however, and I can cross over down again if it was there, or cross over down again if it was there. I can keep on getting entries until I run out, and then I go to a new row. Cross down, cross over down. Last row, cross down, cross over down. Just thinking you're matching up, multiplying as you go across, as you go down, multiplying, adding, multiplying. Okay. So, let's have some fun. How about this guy? First of all, hey, don't groan. See if it's legal, because if it's not legal, what do you get to do?
No solution.
So is it legal?
No.
Okay, there's wishful thinking, and then there's actual thinking, so hold on.
I mean, it does have. I make me kind of wishful thinking now.
I think we should just like
That's
make
dangerous.
the law so strict that everything is no solution.
I think that's the smartest thing.
So you don't want to learn. Okay. So how's that job going to go in the future someday?
I'm gonna work at McDonald's.
That is not good. No food businesses.
There you go, Jaden. It's time for you to share some of your life lessons.
Much, man. What about Brian?
Dude, it's slave work. It's honestly.
Slave work.
And you smell like McDonald's every day when you go home.
Yeah, and like the free meals you would get would be McDonald's.
You want to go hang out with friends and be like, yeah, it smells
I
like
want to
Frank's.
work at Taco Bell. I want free meals.
It's even worse.
Like I get a free sub every time. Like that's what my dinner is every time.
Bro, I'm looking at guitars and I'm like you guys.
Alright, so now that we're trying to somehow work our way around like the reality of life that we're faced with and you can't really avoid, let's put our brains to something productive.
Reality can be whatever I want.
Just let me know how life turns out. Okay, coming back. Not to say that how you think and feel and it doesn't affect your reality, but, or at least your perception of reality, which kind of.
Oh, it's Pega.
Question: legal or not legal?
Yes.
When?
I don't know.
Yeah, because I'm not gonna say
Question.
when I work.
Okay. Life lesson later.
3 times 2.
It's gonna be a 3x2. Good. Those ones match, which means it's legal, and I know the size of my overall result is gonna be a 3 down and a 2 across. I am not gonna show all the work because I can do some mental math. The question is, can you?
No.
KJ, you tracking?
KJ,
Yeah.
KJ's simping.
Here we go. No, his eyes are open. He's smirking to himself back there. Okay, you ready? Here we go. First one's first. What do we got? 0.
You sound
-4 is -4. +2 is -2. Anybody get there before me? Do you need to show your work? If so, do it. Alec, I swear. Put that phone. 0. -4 +2, unless you're researching. Good jobs. With annual income over, that does not require a high school degree.
Ooh, shoot. I'm not gonna get it either way, so.
Actually, these days, you can put in a college degree, because even if you couldn't get the job without it, you're going to have 1,012,000 applicants that do have it.
Oh yeah, it's so hard. When I had my interview, there were 50 people there.
Speak to Kyle about it.
Oh, he's been complaining to me every
We're
single
having a
day, and like I'm like, I honestly,
you
I'm
leave.
just like, yeah, that's a,
0 times.
Be sympathetic, but you do.
yeah, exactly.
Alright, are you guys over? Crossover now?
I know that.
0 +5 +12. Anybody? Are we doing okay? Worst comes to worst, point. I make HPrecalc, like literally put their pen
17.
down and point. But 0 +5 +12, Izzy's got it. She's back. 17.
0 + 5.
Good morning.
Oh my god.
You see it?
Oh,
Boom,
geez.
boom. You just gotta be able to do mental math. If not, write it out the same way I did. I'm just like, oh, we can't.
Yes, I am cheating.
Wait, are we gonna be able to use the calculator for this?
That's the reason I made them cheat.
Half an hour.
So we're gonna do this thing.
Alex, how are we doing?
I
Walk me through. Ready? Walk me through.
2 and 6.
Is
12.
12.
plus,
0.
plus,
What is that? 2 and 1. 3 1 3.
so 12 + 0 + 3. 12 + 0 is 12 + 3 is 15.
Let's go. I'm big brain. How
We
am I
good?
in this class?
Okay, finish off the matrix if you have not yet. I know a few of you have, but a few of you haven't. For those of you that have, can you multiply the other way? Don't answer, try. And then write down what you think the result is.
Mental math.
And then if you want to be interesting or interested, try doing a squared.
Uh-oh.
Must be English.
Yes, it's not 941. We should put that in the Kill Me Puppy card.
Why would?
It's not 941.
Oh. Well, why is that considered?
Illegal.
Kill Me Puppy
It's
is
illegal.
Is that like
Illegal.
distributing?
Illegal.
Illegal.
Gibbs?
Leave me alone.
I'm not talking about you.
-6, 0, and 18 will be
12.
14, -4, and 8.
18.
-7 + 5 + 48.
46.
Woo! What order did you guys do that in? Just the way
My
it was?
calculator.
Oh. Where did you do 48? + 5 is 53. -7 is 46. I don't know which way the easy way is.
What is never mind. Okay. Okay, now.
-7 + 5. That's probably the best way, right? And then 2, and then 2 is 48. -2 and 48 is 46. Check. How about B times A? What's going on when we do that?
Illegal.
What? Why? B would be a 3 by 2, and A would be a
3 by 3.
So why even worry about doing work if it's not going to work out anyway?
If I get it, anyhow.
No solution. Don't use that as a life lesson.
What's the life lesson?
I mean, what isn't a life lesson?
Everything that I say is not a life lesson.
Yeah.
You should do the complete opposite.
Alec, I kind of figured that part out.
Not wrong.
Thank you, Chief.
Okay. So did you guys write out A again?
No, I didn't have to.
It was really easy. It's 18, 11, and 6.
Oh, poor Alec.
Did I not do it right?
Pause. He didn't do 941. Thank you. Because 941 was wrong.
Wait.
Because you can't just distribute a negative. Squares are not multiplications. Pause. But isn't squared really just A times A?
Yes.
Wouldn't A times A mean we need to go across and...
What?
Down.
Speak English.
Ready? Alec. I can't go down.
Oh, wait.
It's impossible.
It's a 1 by 3 by a 1 by 3.
Oh.
So I can't go...
Wait, what tells you?
So
What tells you?
I need the orders of the in-between or the middle to match because I need to be able to go over and down the same amount to pair them up.
Oh.
So when I was able to go here, it was fine. Da-da-da-da. When I made, well, if I tried to go the other direction, it's hard to visualize, but I wouldn't have been able to complete the pairing.
Okay.
Pairing is a 3, but this one I can't even go. Yeah. So I have to go across and down. So no solution. Yeah.
So that means you can only square matrices.
Ooh. Did you guys hear that? You can only square matrices. You can only multiply a matrix by itself if it's the exact same order.
Yes.
Yes. You can only square matrices. I think that's something that we could remember. Okay.
Oh, gee.
So, properties of matrix multiplication. Way back when, we didn't have any matrix multiplication. We were adding, we were subtracting, we were multiplying by scalars, but now that we've learned what matrix multiplication is, some of these are just like straightforward, but there's the one that's missing, which is never true. I guess I shouldn't say never true. But it's not always true, which means it can't be a property. It's not always true, which means it can't be a property. Not always true. Wait a minute, but wait right here. It's sometimes, yes, I said it sometimes is true, just not always true. When's the commutative property of multiplication sometimes true with matrices? When you're multiplying by whose I? Identity. When you're multiplying by the identity matrix.
Do you want us to write the property?
Nah. There's one I would write if I were you.
Let's do
I would write that is not, the commutative property is not true. I think that's helpful and something that our brains don't naturally necessarily think about. I would definitely say this one's not true. And the other one that might be confusing is this one-ish. Because C, I don't know, just a few of you guys would want to take this C into A and B. I mean, if it was written out as a formula, I think if you were just solving it, you wouldn't. But I don't think you need to write this whole thing down. Don't think you need to memorize it. Just remember, this one is not true. Commutative property is not always true. And to be honest, it's rarely true. Even better than that, it's only true with the identity matrix being matrix B. But number 4 is one that we do sometimes confuse because you see parentheses and you think distribute. But distribution is only when we're multiplying cross addition or subtraction. I guess kind of 2 and 3. I don't know if you need to write them down, but pause. Remember how vectors, you needed the initial first and then the terminal, and like it mattered which point PQ or QP, it mattered which one came first?
Mm-hmm.
Okay, matrices, very similar. If I'm distributing A, and if it's in front, I have to make it in front of both of those matrices that I'm multiplying it by, or if I'm distributing C and it's at the end, I have to make sure it's at the end. I guess there are a couple things that might mix you up. Just because this isn't true, we just have to be a little bit more aware. If we're distributing from the front, that needs to go multiplied to the front. And if we're distributing from the back, we need to make sure that's at the back of the expression. Priyanka.
When we have a problem like 2 or 3, are we not allowed to add them first? The ones that are independent.
You are allowed to add them first if possible. Remember, we can only add when they're at the exact same order. So it could be possible that this is something like a 3 by 1. So all I need is, a 1 by 3. This could be something like a 1 by 3, so it has 3, and he has like 3 by 2, but maybe he's 3 by 3. Does that make sense? So I'm not saying that that's necessarily something that happens often, but yeah, if possible, you can add first and then multiply. That's totally fine. Just if you do need to distribute for some reason, if it's in the front, keep it in the front. When you multiply, if it's in the back, keep it in the back. We can't go switch in that order because this commutative property is true. All right, I guess we should have talked through some of those. Sorry for making it a little bit too fast. Let me do a dual screen. Beep, beep. But the one exception to this rule is the identity matrix. Now, I don't necessarily, like some of you do need to write out all of this multiplication addition stuff to stay, to help your brain kind of process it and get there legally. But for these problems, I just don't want you guys to write a lot of work. I'll do the work, and then you guys just see if the answer makes sense. Because technically, you should be able to look up here and say, any matrix times the identity should be itself, right? Any matrix times the identity should be itself. But how does that make sense? We'll check it. First times first, wouldn't that be 3 plus 0, 0? Stays 3. Second one, cross over down. 0, negative 2, 0. Oh, stays negative 2. Cross over down. 0, 0, 5. Literally, as you go through multiplying with the identity matrix, you will end up each and every term staying the same because of the placement of the 1s and the 0s. It's not just this snazzy like, ooh, 1s and 0s, ta-da! 1x equals 1y equals 1z equals when augmented, like section 8.1. It actually works, and it doesn't just work one way, it works the other way, especially with matrix multiplication of 3, 0, 0. Oh, still 3. Negative 2, 0, 0. Oh, still negative 2. So whether you multiply the identity on the right or on the left, in front or at the end, the identity matrix is the one that you can multiply back and forth. But as Priyanka already said, this only works when you have square matrices, a 3 by 3 times a 3 by 3 identity. Or a 4 by 4 times a 4 by 4 identity. Or a 2 by 2 times a 2 by 2 identity. It only works when you have square matrices. And thus a square identity matrix. So, what is the identity matrix? It is the multiplicative identity. The multiplicative identity. That's who he is. The multiplicative identity of the matrix. Any number times 1 is itself. Any matrix times its identity matrix is itself. So, do non-square matrices have identity matrices? Nope. Only square. Which makes it interesting, because if you encode messages, ooh, cryptography, ooh, the end of chapter 8, coded messages. If you encode a message with a matrix, you cannot undo the code unless you used a square matrix. Kind of having to do with this idea that you just saw. Let's see. I don't know if you guys need to go ahead and write all of this, because all of this is pretty much just kind of reviewing where we've already been in 8.1. Didn't we use our calculator to take a system, to make a matrix, and then to go ahead and solve with RREF, right? Even though we've already done that, though, they could ask something a little bit interesting. Are we there yet? No, I think inverse matrices come in a future section. Oh, the inverse is in section 8.3. Well, we've done the whole augmenting thing, how we take all of our variables and we set them, and we augment them with all of the constants. What you haven't seen is what we actually did when we did that. When we augmented is that we actually factored out, here's the crazy thing, we actually factored out the x1, x2, x3, and we factored out the x1, x2, x3, and we factored out the x1, x2, x3. We're basically undoing the matrix multiplication, because matrix multiplication, we get the x1 in, the x2 in, the x3 in, the x1 in, the x2 in, the x3 in, the x1 in, the x2 in. Anyway, it's kind of interesting when you see it that way. Like, it's not just, oh, random numbers, but actually we're factoring, when the x, y, z's are in the same order, we're kind of pulling them out of the matrix multiplication that was done. Anyway, let's just apply it to the last word problem. We still have 8 minutes of class. Profit. Dairy Mart. Anybody know what a Dairy Mart is?
It's where you buy dairy.
There's one that closed down recently.
There's
one in Santa Clarita right by the bowling alley. It's called, is it called a dairy store? It's like a drive-through convenience store kind of, but they have,
right?
yeah.
We have
It's blue.
the, yeah.
Why don't you just go to a
there's
regular market?
one on-
In Colorado, my parents lived there for a few years when I first started teaching here. And they had like, I think it was called milk store or dairy store right down the road. Anyway, it used to be a thing. Don't stress about it. Pause. Come back. What I want you to see in this word problem is how matrices can be used to organize information. Because right now it's like, whatever, systems of equations are cool. Matrices are a shortcut. But sometimes using these, what they're called rectangular arrays, ooh, snazzy, rectangular ARRAYS arrays, can be like a profitable way of organizing information. So here we go. Local Dairy Mart, the numbers of gallons of skim, 2%, and whole. 3 categories of milk. Over the weekend, okay, pause. By weekend, we mean, in the business sense, Friday, Saturday, Sunday, okay? In a business sense, Friday, Saturday, Sunday, that's the weekend, right? Okay, so we have 3 days, we have 3 types of milk. I wonder which 3 is which, because they didn't really label the rows or columns, right? The selling prices in dollars per gallon and the profits in dollars per gallon for the 3 types of milk sold by the Dairy Mart are represented by B. The selling prices in dollars per gallon and the profits. Okay, hold on. This is a category of 2, right?
Yeah.
So where do we know that these 2 go or label?
One row and the other row.
But which one's which? Not row, column. So dollars per gallon. Well, they're both dollars per gallon. Careful. Yeah, so this is the price, selling price, and this is the, wait a minute, why is profit so much lower? That's how the world works. Yeah, you sell it for more and then you only make part of that because you have to spend money on
Business.
delivery and employees and renting the space and blah, blah, blah. Buying the milk from someone unless you have the cows in the back. Anyway, for the 3 types of milk, for the 3 types of milk, so how can I label my columns? Sorry, my rows. How can I label my rows then? Skim. 2%. He apologizes, just focus. I think. Nope, he doesn't. Okay, still focus. So guys, hold on. If they tell me to compute A times B, and if there's an interpretation to the result of A times B, how can I label the original matrix based on what I just figured out are the rows and the columns of this matrix? Can you figure it out? Priyanka.
I have a question.
Oh, okay.
How did you know that skim 2% and whole go in that order?
Because unless they say otherwise, we assume that the order in which the information is given to us is on purpose. In like AP problems, they say something like respectively, so we know to match them up kind of in a proper way. Yeah, that's a good question. But for this purpose, we'll just say we're going with what they're giving us. Same reason that we'll put Friday, Saturday, Sunday in that order because it's chronological. We'll assume the skim 2% and whole is purposeful in how they order it. Same thing with selling price and profit. Well, that would make sense. What's this? Is it Friday or is it skim? Based on context of I'm multiplying by this.
I think it's Friday.
So, Friday, Saturday, Sunday?
Yeah.
No. Why is that not? Because that's the skim 2%. Why does it need to be skim 2%? I need the column to match the row.
So is skim and Friday the same thing?
Nope.
Friday.
So where's my Friday, Saturday, Sunday? Oh. See it? How does that make sense?
Oh.
I sold 40 units of skim at $3.45. I sold 64 units of 2% at $3.65, and I sold 52 at $3.85. Do you see it? It's the only way that makes sense. But I sold all of this on Friday. I sold all of this on Saturday. I sold all of this on Sunday. Ooh, people are getting in right before the beginning of the week. Like Trader Joe's, don't go on Sunday. I usually do, but still it's busy. Monday's even worse because everything's empty. So what's going to happen when I multiply? Do you guys, hold on, what size am I going to have? This is a 3 by 3, right? Times a 3 by 2. What's my AB? What size is it going to be? A 3 by 2, right? And even more than that, what are the labels of those 3 and of those 2? I'm going to have my price and my profit, how much money I got in, but how much of it was profit. And what are my rows going to be? Here's another application of why we need these two to match, because technically they're meant to be the exact same thing. And then what do I get when I do all of this? How much did I get in on skim milk in the cash register? 2% in the cash register. Full milk in the cash register. Add it all up. How much do I have in the cash register from Friday? How much of that is profit? Ooh, you could do that with however many products you have and their prices if you put them in rectangular arrays. One matrix multiplication, you can say like, haha, I multiply the units by their prices and added it all together. I don't know, Microsoft Excel does all kinds of snazzy stuff too. But yeah, you'll get the price and the profit. Hold on, wait a minute, but what about part B that says, okay, if you were to plug this in your calculator, yes, it wouldn't be by hand. Plug that in your calculator, do the multiplication the way we learned at the beginning of class. You would fill in this matrix. What's letter B asking? Total profit. How would I find the total profit? If I've done the matrix multiplication, all I have to do is just say, hey, add all of those columns, however many they are. What are all the profits added together from Friday, Saturday, Sunday? Do you kind of see how information could be put into matrices where you're not just measuring the when, but you're measuring the money and you're putting them together to figure out the overall when and the money? Anyway, something interesting, matrices, 8.2 due on Monday. You guys good? Have your calculators over the weekend. That would be my advice. Not that you're